A 50 kilogram box is dragged on a horizontal floor through a distance of 1.5 meter by a force of 300 Newton, and the force acts 30 degrees above the horizon. Coefficient of friction of the floor is 0.2. Okay, question number 1. Sketch a label diagram showing all the forces on the box. Okay, first we draw the box on the floor, and then from the question we know there are 4 forces acting on the box. The first one is of course the applied force, F. And it is applied at 30 degrees above the horizon. And the other one is of course frictional force, F. Next is the weight, mg, and of course last is the normal force, N. So if we reduce the 50 kilogram mass box to a point mass, we can draw all the forces also, F, mg, friction, and normal. Okay, question number 2, calculate the normal force. Okay, since normal force acts vertically upward, so we have to consider all forces acting in the vertical direction, in the y direction. So we have to write the force equation that is associated in the vertical direction. Okay, so what are the forces that acts in the vertical direction? Of course, we have normal, we have the force of gravity, mg, and we have force F, which is a component of it along the y-axis. So the force equation along the y-axis becomes normal is upward plus force F in the y direction will be F sine theta, and of course we have mg, which is downward, minus mg, equal to 0 because there is no motion along the vertical direction. So from here we can get the expression for the normal force. So N equal mg minus F sine theta. So we plug the numbers. Therefore N is equal to 340.5 Newton. Next, question number 3. Calculate the acceleration of the box. Okay, for the acceleration of the box can only accelerate due to net force along the x-axis. In this case, along the positive x-axis. So net force to the right is actually mass of the box, and its acceleration is equal to force to the right is the component of F along the x-axis, which is F cos theta, minus the frictional force which acts in the negative x-axis. So F. So MA equal F cos theta minus frictional force. But frictional force can be written as mu normal. Therefore, that's equal to 300 cosine 30 degrees minus mu n, 0.2 multiplied by 340 40.5. This equal to 191.7. Therefore, A is equal to 191.7 divided by m, 50 meter per second squared. 3.83 meter per second squared. And the fourth part of the question is to calculate total work done on the box. Okay, total work done is calculated using the resultant force or net force multiplied by the box displacement. Work done, W, equal F net multiplied by displacement, which is equal to this is equal to 191.7 multiplied by the displacement is said to be 1.5 meter. So therefore, work done is equal to 287.6 joule.